Okay, look at the first question, integral of the cotangent. Don't think about answer, it's a cosecant square or secant square. Answer is not. We have to do U substitution. Before you do U substitution, let's change this to cosine over sine. And then U is a sine x. Du is a cosine x. So this cosine x will cancel this cosine x and with a dx. So we will left this as integral 1 over u du. And you're going to have a natural log of the u. And then change your u back to sine x. Plus it. Okay. So same thing. If we have a tangent, we also change this to sine over cosine. And doing u substitution, u is a cosine this time. So du will be negative sine. So answer will be integral 1 over u, but with a negative sign in front. So answer will be negative natural log absolute value of the cosine x plus it. Okay. And the next one. Integral negative 1 to 0 dx over e power 5x. We rewrite this question to e power negative 5x first. And then we take integral of the e power negative 5x. That will be e power negative 5x. Because there's a baby here. So you have to put negative 1 over 5 in front. This negative 1 over 5 actually comes from the u substitutions. So if u is negative 5x, du will be negative 5. That's where the negative 1 over 5 comes from. And then if I change my u back to the x, I need to keep the limits. So I plug in limits, that will be negative 1 over 5 e power 0. Subtract negative 1 over 5 e power 5. And the e power 0 is 1. So we will have a negative 1 over 5 plus 1 over 5 e power 5. That would be the answer. And the next one. This one we're using u substitution. U equal to x squared plus 1. So du is a 2x dx. This x dx will cancel this x dx. So we still have a 2. So we rewrite this question to 1/2 and the 1 over u du. So it will be 1 over 2, natural log of u. If I keep u, that means I have to change the limit. I'm using this equation to change the limit. When x equal to 1, and u will equal to 2. And when x equal to 0, u will equal to 1. So when I plug in 1 and 2, so answer will be 1/2 natural log of 2. Subtract natural log of 1. And the natural log of 1 is 0, so that will be the answer. Okay, next one. Dx over 1 minus x. We use u substitution. U is 1 minus x, so du is negative 1. So we will have negative in front and the 1 over u du, which will be negative natural log of u. And change your u back to 1 minus x and plus it. Next one. Dx over x squared plus 4. This is arctangent formula, but be careful of this number. The arctangent formula is x squared plus a squared. So if a squared is equal to 4, that means a going to be 2, not 4 anymore. So you can just rewrite this to your answer. It's 1/2 arctangent. And then x over 2 plus c. That's it. That's how we do for the arctangent. And the next one. Integral dx over 1 minus x squared. This is arc sine formula. And this is 1. That means you don't have any x over number for your formula. You just rewrite this as arc sine. And the x plus c. That's it. Next one. This one has infinity on the limit. So this problem going to be improper integral. So we have to have a limit notation at the beginning. And the integral 0 to b. And this b will approaches to infinity. And this question, when we have a 1 over x squared minus 7x plus 10, by using partial fraction, you need to factor this denominator. So we factor this to x minus 3, x minus 5, and x minus 2. And keep 1 on the top. After we factor this denominator, you're able to separate this. So we plug in x equal to 5 back to this fraction by cover this factor. And that will be 1 over 5 minus 2. So which will be 1 over 3. And we plug in x equal to 2 back to this fraction by cover this term. So that will be 1 over 2 minus 5. So which is negative 1/3. And 1 is a positive 1/3, 1 is a negative 1/3. So we can put the 1/3 at the beginning. And then that will be natural log. The positive 1 should be on the top. The negative 1 should be on the bottom. And the limit is from 0 to b. And the b is approaches to infinity. And now let's plug in the limit. When we plug in infinity, so you will have an infinity over infinity. And for this question, which is equal power, when you have an equal power, the leading coefficient will be answered. So this is 1, this is 1. So you're going to have a 1/3 natural log of 1. And subtract, when you plug in 0, you have a 1/3 natural log of 5 over 2. And the natural log of 1 is 0. So this whole thing will be gone. So answer just be negative 1/3 natural log of 5 over 2. Next one. For this question, when we have a single term on the denominator, we need to separate these fractions. So we rewrite this to 5x squared over x over x, and the 1 over x. So x squared over x actually will simplify to just 5x, and that will just be 1. And you can keep this as 1 over x, or if you want, you can change to x power negative 1. And the integral of the 5x is 5x squared over 2. And the minus x, and the integral of the 1 over x is a natural log of x. And the limit is from 1 to 2. So when we plug in 2, this will be 4 times 5, 20 divided by 2, 10 minus 2 plus natural log of 2. Subtract. When we do 1, that's a 5 over 2 minus 1 plus natural log of 1, which will be 0. And then we do 10 minus 2 minus 5 over 2 plus 1, because negative will be plus. And after we've done this, you're going to have 13 over 2, and then plus natural log of 2. So that will be our final answer. And the next one. We're using u substitution. U will be what terms you have inside of the square root, 1 plus ax squared. So du is 16x dx. And x dx will be cancelled with this x with this dx. You still have a 16, so we put 1 over 16 in front. And that will be u square root of u, so it is u power 1/2. And by doing power rule, we have a 1 over 16 and a u power 3 over 2. And the over 3 over 2 means we times the reciprocal. So we have 2 over 3 here. And when we simplify these two fractions a little bit, which will be 1 over 24. And change your u back to 1 plus ax squared and keep the power 3 over 2 plus 6. Okay. Next. Same thing, one single term on the bottom, so you're able to separate this, which will be integral of x cubed over x squared plus 5 over x squared, and which is integral of the x plus 5x power negative 2. And then you can take integral individually. This is x squared over 2. This will be 5x power negative 1, and over negative 1, that's why I change this to minus, and the plus 6. And you can leave there. You don't have to simplify this negative sign. And next one. So this time we do u substitution. So u is x cubed plus 2. So du will be 3x squared dx. And x squared dx will cancel this x squared and this dx. So we will have integral of 1 over u squared du. And then we left the 3 here, so you have to do 1 over 3 in front. And look at this question. We have infinity as our limit again, so you have to put limit notation in front. So b is approaches to infinity, 1 to b. And then after that, you can do power rule for this one. This actually is u power negative 2. So by doing power rule, we have u power negative 1 over negative 1. And you have a 1 over 3 in front. Keep your limit notations. And this is from 1 to b, not 1 to b anymore. Because if I keep the u, I have to change the limit by using this equation. So when x is 1, we're going to have a 3. So this number going to be 3 right now. When x is infinity, infinity plus 2 still infinity. So you're still able to using this b when b approaches to infinity. And when I plug in infinity here with the negative power, that actually will be bottom heavy. When you have a bottom heavy, limit going to be 0. So 0 minus negative 1/3. And when you plug in 3, this is 1/3. And the negative answer will be positive 1 over 9. Okay. Next one. This one we have x with some power and the e power x. So we can do this by parts. And when you do parts, you either can do u v things or you can just do tabulars. The tabulars will be much easier for this question. So when we're doing tabulars, we always start with a positive sign and alternate to negative, positive, and negative. And the second column will be the terms you're able to get 0 by taking derivative. So for this question, we're going to using this term as the middle one because we're going to take a derivative of this and get 0. So 2x squared here. Derivative of this is 4x and 4 and 0. So last one will be e power negative x. And we're taking integral of this term multiple times. So first time will be e power negative 2x, but you should have a negative 1/2 in front. You apply the chain rule. Next one will be 1/4 e power negative 2x. And then when you do one more time, will be negative 1/8 e power negative 2x. And then you're able to have your answer. The answer you just do diagonal. We do this one with this one. So this 2 will cancel this 1/2. So you will have a negative x squared e power negative 2x. And next one will be negative 4x times by this. And the 4 with 1/4 will be cancelled. So we have a negative x e power negative 2x. And the last one is a positive 4 and the times this. And the 4 times 1/8 will simplify to 1/2. So we have a negative 1/2 and e power negative 2x. And then plus c. That's how we do in tabular. Next one. For this one, we do partial fraction. So we factor the bottom to x plus 3 and x plus 4. Then we separate this. When we're doing this, that means x equal to negative 3. So plug in negative 3 back to fraction by cover this factor. So it would be 2/1. That's how we get 2. Then by doing this, x equal to negative 4. We plug in negative 4 back by cover this. So it would be 1/-1, which is negative 1. And now we're able to have your answer by taking integral. So 2, just 2. In natural log x plus 3. And the negative, so it'll be minus 1 times natural log of x plus 4. And the plus c, that's it. This one. We're using u substitution. U will be natural log of x. So du will be 1/x. And the dx. This will be cancelled, this x and this dx. So we still have a 4 from the question. This time you are not reciprocal this because that's the number you left over from problem, not from your du. We just keep what we have. 4 is on the bottom, so actually that will be 1/4. And this will be u power 4. And by doing power rule, so it will be u power 5/5 times 1/4. So this will change to 1/20. And the last step, just change your u back. So 1/20 natural log x power 5. And the plus c. Okay, next one. 0 to 5. X e power x squared dx. We're not doing tabulars for this one because we have e power x squared, not just e power x. So we do u substitution. U is x squared, so du is 2x dx. And this x dx we cancel here. And then we still left 2, so we should have a 1/2 in front and e power u du. And the integral of the e power u is e power u. If I keep my u, that means I need to change the limit. So by using these equations, when x is 0, 0 squared is 0. And when x is 5, 5 squared is 25. So final answer will be 1/2 e power 25. Subtract. When you plug in 0 to here, e power 0 is 1. And the times 1/2, so that's just be 1/2 here. Okay, next. Integral e power x over 2 e power x plus 6. we do u substitution. U is 2ex plus 6. So du will be 2e power x dx. And e power x dx will cancel this e power x dx. And we still have a 2 here. So we should rewrite this question to 1/2 integral and 1 over u du. And the integral of the 1 over u is natural log. And the change u back to 2e power x plus 6 and a plus a. Next one. Don't think this is arctangent. The arctangent formula, you should have a plus. And the arcsine formula, you should have a square root. This has none of them. So you have to do something else. 25 minus x squared. You're able to factor this to 5 minus x and the 5 plus x. So we do partial fraction. And then we separate this to 5 minus x and the 5 plus x on the denominator. We're trying to figure out what the numerators are. When we're doing this, that's x equal to 5. So plugging x equal to 5 to these fractions, by cover this term. So it'll be 9 over 10. And when we're doing this one, x is negative 5. So by plugging negative 5 to here, by cover this term, 5 minus negative 5, that will be plus. So we also have a 9 over 10. And when we have a same denominator, you can have 9 over 10 here, and the natural log of 5 minus x. You have to put negative sign in front for this one because there's babies here. We have a subtract x. That's why you have a negative sign. And you don't have a negative sign for the second one because we have plus x. And that's your answer. If you want to keep simplified, you can do 9 over 10 natural log and rewrite this as a single natural log with a division. The term with a positive one going to be on the top. The one with a negative sign, that will be on the bottom. And a plus 6. That's how you simplify. Okay, next. For this one, we rewrite this to x power negative 1/2 first. Then you're able to do the power rule. So which will be x power 1/2. And when you divide by 1/2, that will change to positive 2 in front. And where this 1/2 from? Because you add 1 to this exponent. That's how you're able to get a positive 1/2. And now let's plug in 0 to 1. When you plug in 1 power any number will be 1. And when you plug in 0 power anything will be 0. So answer just be 2. Okay, one more. We have x squared plus 6x plus 8 on the bottom. And you're able to factor this function. So we're doing partial fraction. Another thing, when limit is infinitely, you should know that's improper integral questions. So make sure you have your limit notations. And then rewrite this to 0 to b, and the b is approaches to infinitely. And the a over, when we factor this one, you will have x plus 2 and the x plus 4. After you factor the denominator, we're able to separate this as a 2 fractions. One with x plus 2 on the bottom, another one with x plus 4 on the bottom. And now we're trying to figure out the numerator. We do x equal to negative 2, and plug in back cover these functions. So that would be a over 2, which give you 4. And we plug in x equal to negative 4 to these fractions, and by cover this. So that would be a over negative 2, which will give you negative 4. So we will have 4 times the natural log of x plus 2, subtract 4 times the natural log of x plus 4. And the limit is from 0 to b, when b approaches to infinity. And this question, when you plug in infinity, you're going to have an infinity. Subtract infinity. It's hard to tell what's the answer for that. So that's why you have to simplify this. We rewrite this to single natural log. And the following from natural log, when you have a subtraction, we should rewrite this as a division. And the one with a positive coefficient should be on the top. And the one with a negative coefficient should be on the bottom. And now we're able to plug in the limit. And when you plug in infinity, this is going to be equal power. And this is going to be 1. So you're going to have 4 times natural log of 1. Subtract. And the 4 times natural log, when you plug in 0, this just be 2 over 4. And which will be natural log of 1/2. And the natural log of 1 is equal to 0. So this whole thing will be gone. Answer will be negative 4 natural log of 1/2. That's all the questions we have done in class about the matching game. And I'm going to talk about 2 more questions because these 2 from your test 3. And lots of you missed that 2 questions. So I realized I should go over this a little bit. So these 2. First one, that's question number 3 on your quiz 3. 4 over 3x squared plus 14x minus 5. And then we factor this. So 3 times negative 5 is negative 15. And then we factor this to 1 and 15. I need a positive 14. So the bigger number need to be positive. This will be negative. And then divide by leading coefficient 3x. So I bring this down. That will be 3x minus 1. And this one is now 3x plus 15. You have to simplify this to 5 over x. So that's why we have x plus 5 here. And now we're able to plug in. When we plug in 1/3 back to fractions, by cover this, we're going to have 4 divided by 1/3 plus 5. And that will be 4 over 16 over 3. And the divided by fraction means you multiply by reciprocal. So that will be 3 over 16. And you can simplify this to 3 over 4. So this is going to be 3 over 4. And when we plug in x equal to negative 5, so that would be 4 over negative 15 minus 1. So 4 over negative 16, which will be negative 1 over 4. So we have a 3 over 4, and the integral of this will be natural log 3x minus 1. Be careful, we have a baby, so you have to put 1/3 in front. And minus 1 over 4, natural log of x plus 5. There's no baby, you can just stay as a 1 natural log. And we simplify this 3, so it'll be 1 over 4 for the first one, and 1 over 4 for the second one. They both have a 1 over 4 as a coefficient, so I can rewrite this to 1 over 4 times natural log with 3x minus 1 divided by x plus 5 and the plus 6. That's how we do this. And there one more question. That's the last one on your test. It's a 4x plus 6 over 4x squared minus 1. When we factor this denominator, that will be 2x plus 1 times 2x minus 1, because that's the difference of the perfect square formula. So when we're using this, that will be x equal to negative 1/2. Okay, so we have 2x plus 1 here. when we plug in negative 1/2 by cover this, negative 1/2 here will be negative 2 plus 6 over negative 1 minus 1. So that will be 4 over negative 2, which is negative 2. And for this one, x is 1/2. So by plugging 1/2, by cover this, so it'll be 2 plus 6 over 1 plus 1. So 8 over 2, which is 4. And for the first one, negative 2 natural log of 2x plus 1. Same thing, we have a baby again. You have to put another 1/2 in front. And this one, natural log of 2x minus 1. There's a baby, so you have to put a 1/2 in front. So final answer will be negative 1 natural log of 2x plus 1 plus 2 natural log of 2x minus 1. And the plus it. That's how you solve these questions. That's the last question on your test. And that's it. This is my first video, so hope it won't that bad. And I hope you can prepare yourself tonight, practice more, and doing good tomorrow on the test. Have a good night.